TCON. Then serial control SCON, location number 98 is used for serial control. Then A8 is for interrupt enable, means used to control the interrupts. Then B8 is used to control the interrupt priority. Then D0 is a program status word PSW, that we generally called flags. And then location 87 is power control PCON. Then the green labeled special function registers, this is the third group. In this E0 is the address for accumulator, then F0 is the address for register B, then stack pointer, data pointer low, data pointer high, then timer low for timer 0 and timer 1, same timer high TH for timer 0 and time 1, and serial buffer. So, this is the third group of special function registers. Now, let us discuss one by one these major blocks of the architecture of microcontroller, the major architectural parts of this microcontroller. First one is accumulator. So, accumulator is nothing but a register, it is a general purpose register. This register is used for storing intermediate results which are obtained during the operations. Prior to executing an instruction upon any number or operand, it is necessary to store it in the accumulator first. In most of the instructions, when we are going to perform a operation upon two numbers or two digits, one of them should be stored in the accumulator. So, all the results obtained from these arithmetical operations performed by the ALU are stored in the accumulator. The results are automatically stored in the accumulator. Next, data to be moved from one register to another must go through the accumulator. In data transfer case, the data moves through the accumulators. Most advanced features have some advanced instructions also, but in basic microcontroller, accumulator is used for this data transfer. In other words, A register is the most commonly used register, it is the most commonly used register, and it is even impossible to imagine the microcontroller without this accumulator. More than half of the instruction used by 8051 microcontroller somehow use this accumulator in. For example, in multiplication and division, these instructions, these operations can be performed only upon numbers, those are stored in accumulator. One number should be stored in accumulator, the other number should be stored in register B, that we will discuss next. During the process of writing a program, each register is called by its name, so that their exact address are not of importance. We can call these registers by their name also. For example, register A, register B, then R registers R0, R1, and we can use their address also. Now, next register B is also a general purpose register, it is very similar to accumulator, it is a 8-bit 1 byte register. So, in some instructions this register is used compulsorily. For example, in multiplication we can multiply the two numbers only if they are stored in register A and B. In divide and division also, the number should be stored in register A and B. It is mandatory that one number should be kept in accumulator and other number should be kept in the register B. Next group, next architectural feature is the R registers. As I told, the lower 32 locations of RAM, this is a common name of R 8-bit general purpose register. They are commonly known as R0, R1, R2 or R registers. Even though they are not true special function registers, but they do the same purpose, they are used as general purpose register. These registers are occupied in 4 banks, 8 register per bank, so 32 in total. So, similar to the accumulator, they are used for temporary storing variables and intermediate results. Now, which one of block this should be used, it depends upon the control bits of the program status word PSW register. So, PSW register is used to select the bank. Now, let us just have a look at the operations of accumulator and registers. Suppose in this first example is move A into R3, means the contents of R register means register R3 of the selected bank, they are copied to the accumulator. In next example, the contents of register R4 R register of the selected bank, they are added with the number in the accumulator and the result is stored automatically in the accumulator. Third example, the contents of accumulator, they are copied or moved or stored in the register R5 of the selected bank. Next, the contents of register R1 R1 of the selected bank are copied to the accumulator. And similarly, the contents of R2 register are added with A and result is stored in the accumulator. Now let us discuss program status word PSW. This is the important part of an internal architecture. So it is an 8-bit register, but it is the most important special function register. This register is also called a special function register, as it is a part of the special function register group of 21 registers. This register contains several status bits that these bits are used to reflect the current status of the CPU. So these bits are carry bits, auxiliary carry, then 2 register banks bits are selected used to select register banks, then 1 bit is used to use as a overflow flag, then parity bits, and some are user definable status. First come at the parity bit. So this bit will be automatically set if the number of ones in a accumulator is even. If in a accumulator the number of ones are even, then this parity will be set, otherwise it will be reset or it will be cleared. So next bit 1 second location bit, they are not used in this microcontroller, this is used for future versions. Overflow flag, this flag occurs when the result of the arithmetical operation is larger than 255, means larger than FF in hexa, larger than when the result is larger than the operating capacity of the microcontroller, then this overflow flag sets, means it indicates that there is a overflow, means the result is greater than the capacity. Next 2 PSW bits named RS0 and RS1, these are register select bits. So 2 bits means these 2 bits can select 4 register banks, means when it is 00 on both these, bank 0 is selected, when it is 01, bank 1 is selected, when it is 10, bank 2 is selected, when it is 11, then register bank 3 or 4th bank is selected. So these 2 are bank selected registers. Flag 0, it is for future use. AC flag, this is auxiliary carry flag, it is used in BCD operations, means if there is a carry from lower neighbor, lower 4 bits to the upper 4 bits, then this auxiliary carry will be set. Carry flag is nothing but the 9th auxiliary bit, means it is the extra bit. If there is carry to the 9th bit, then this bit will be this carry flag will be set, otherwise it will be reset. Now next part is data pointer. Data pointer is nothing but a true 16-bit register, but it is a combination of 2 registers. DPH means data pointer high and DPL means data pointer low. These 2 8-bit register combines and makes a 16-bit register, which is called data pointer. This register is used for generally addressing the external memory addressing, as 16-bit address is required for addressing the external data in program memory. Next is stack pointer. Stack pointer is a register. This register points to the first free stack address and it permits the stack availability. So in the push statements, this stack pointer is automatically incremented by 1, and in the pop instructions, this stack is automatically decremented by 1. So by default, on reset or power on, 07 is stored in the stack pointer, means stack pointer is 07 by default in the RAM location 07, but we can modify it also. Program counter is a 2-byte address, it is a 2-byte register, 16-bit register, which tells the 8051 from where the next instruction to be executed. So first initially this program counter is initialized as 000, and next onward it is incremented either by 1 or it is incremented by byte 2 or 3 bytes, depends upon the instruction size. These are 4 ports, P0, P1, P2, P3. These are fully bidirectional ports, 4 ports of 8-bit each. So total 32 input output pins are available for interfacing. So these ports it reflects the states of the microcontroller. So these are either 0 or 1, means they are either at 0 volt or at 5 volt. Counters, it has 2 counters. and timers known as timer T0 and T1. These timer counters are used for timing and counting the pulses, or these are also used for generating the baud rate in serial communication. So, both these timers are controlled, may be controlled, they may be set, read, all these functions can be performed by on these counters by using the special function registers. Serial port, it has a full duplex serial port. Full duplex means we can send or receive the data from this serial port. So, this serial port facilitates the fast serial operation. Interrupts. Now, what is a interrupt? So, as you seen in architecture, there was a block named interrupt. So, interrupt gives us a mechanism to put on hold the normal program flow. So, this mechanism is used to put on or hold the normal program flow. Then by holding the normal program flow, it executes a subroutine. So, the microcontroller executes the subroutines, and then it resumes automatically, it resumes normal program flow as if we had never left it. So, means automatically the microcontroller automatically saves the program counter contents, so that it should resume from the same location. The subroutine in this is called an interrupt handler. It is only executed when a certain event is called interrupt occurs. The event may be one, what are these events? They may be the overflow of timers, means these are internal interrupts, or receiving a character by the serial ports or serial port reception RxD pin, then transmitting a serial port, then two external events, means two external interrupts and 4 internal interrupts. The 8051 may be configured so that when any of these events occur, the main program is temporarily suspended and the control passed through a special section of code which presumably would execute some function related to the event that is occurred. So, once it is completed, the control would be returned to the original program, which is called the main program. So, event that can be triggered. So, what are the events that can be triggered internally? That is timer 0 overflow. The interrupts can be triggered by the overflowing of timer 0. Then timer 1 overflow, by overflowing of timer 1, it can also trigger the interrupt. Then in case of serial transmission, reception and transmission of a serial character through serial port can also trigger the interrupts. Then two external event 0, external event 1. Microcontroller has two pins for these external interrupts. So, external interrupts can be applied through these two events. So, this was all about the architecture of microcontroller. In this we have discussed different architectural features of the microcontrollers, starting from its introduction. Introduction means what are microcontrollers, how they are important, means what is microcontroller means, what is its difference from microprocessors. So, it was about the introduction to microcontrollers. Then we have discussed the history of the 8051, the basic 8051 microcontrollers, and the key developments in the future years in this 8051 microcontrollers, which was called MCS51 series. Then we have discussed different major applications like energy management, then in LCD screens, robotics, industries. So, in medical sciences we have discussed the applications to make the concept of this microcontrollers more clear. Then we have discussed the MCS51 family, the family of microcontrollers. It has two active members other than 8051, that is 8032 and 52. Then we came on the main point 8051, which was our main consideration. So, features of 8051 we have discussed in details. It is a 8-bit, what is its RAM, ROM and all other features. Then from architectural point of view, we discuss its block diagram in details by discussing each of its block. Then from this architecture we discuss the memory point of view, the memory architecture in details. So, what are different types of memories available. Then we have discussed counters and timers. then next serial ports, and at last we discuss the interrupts. So, this was all about the microcontroller architecture. Thank you.